Hello everyone, welcome to this video, and in this video we'll see how to remember the divergence theorem and the Stokes theorem. Divergence theorem is given by this relation that exists between surface integral and volume integral. Similarly, the Stokes theorem exists between the line integral and the surface integral. In order to memorize them, you need to remember few basic things. The first thing you need to remember is this sequence. I think it is very easy because this sequence is simply the line and the surface and the volume. That is, line is the first dimensional thing, surface is the two-dimensional stuff, and similarly the volume is three-dimensional stuff. So remember this sequence, that is line, surface, volume. Whenever someone asks you any of these two theorems, just remember, create this image in your mind. And the second thing you need to remember is during Stokes theorem, take this S, take the S of Stokes theorem, and what comes before S, before surface, you have line. As you can see in this sequence, what comes before the surface is line. So in Stokes theorem, take the S, and before S you have L. So Stokes theorem will be a relation between surface and line. In the divergence case, take this V, and so this V, and what comes before V is S. As you can see in this sequence, what comes before V? S comes. So in case of divergence theorem, the divergence theorem will be a relation between volume and surface. Now the third thing that you need to remember, actually the fourth thing that you need to remember, is divergence theorem. In the divergence theorem, you take the dot product of the vector, any vector. This can be A, this can be B, this can be C, or anything. This can be electric field, this can be magnetic field. And similarly, the Stokes theorem will be a cross product. Divergence theorem, dot product, D for divergence, D for dot. What is left is cross, so cross product goes to Stokes theorem. So let us revise the three things that you need to remember. This sequence is the first thing that you need to remember, and these two things, that for Stokes theorem you take the S, and one step back of S is line, that is one step back of surface is line. And in divergence theorem, this is take this V, and one step back to volume is S. So divergence theorem exists between volume to surface, the Stokes theorem exists between surface to line. And the third thing, in the Stokes theorem you take the cross product of the vector, that is del cross A, and the divergence theorem we take the dot product of the vector, that is del dot V. Now let us suppose that someone says, tell me the divergence theorem. So first take the V and V of the divergence. So take this V, and what comes before V is, what comes before volume is surface. So take this, we take this V from this divergence, and this before the volume you have a surface. So we have these two things. Now because we are talking, divergence theorem and Stokes theorems are the relation between the elementary portions. So we take dV and ds. This is very simple thing. And now in the divergence theorem, as we have already told, in the divergence theorem we take the dot product of the vector. So in the volume side, that is, you have surface side, you have the volume side. So in the greater side, volume is the greater dimension, that is V is the 3D dimension and S is the single dimension, 2D dimension, sorry, not single dimension, it's 2D dimension. So in the dot product, we will place the dot product in the higher dimension side, that is, it becomes del dot A dV, and similarly here we simply place the vector over here, A dot ds, and we place the integral sign. And one important thing that you need to remember is that in the vector side, you place this closed loop integral. Similarly, you can use the same trick in Stoke's theorem, that whenever it comes Stoke's theorem, you take the S of Stokes and one step back. S is L, that is surface. Before surface you have line, so Stokes theorem exists between surface and line. And Stokes theorem, in the Stokes theorem you take the curl of the vector. So on the higher dimension side, that is on the surface side, you take the curl of A, whereas in the lower dimension side you take simple vector A. Now integrate it on the simple vector side. On the lower dimension side you place the closed loop symbol. This is your Stokes theorem. Now you can easily practice this trick 2 or 3 times and you will never forget it.